Already our next topic, that is the conjugated molecule. This was basically told by the Bronsted and Lorry. With the help of example, you can easily understand. So this is HCl plus water. So this is basically the acid, as you guys all know, but this is Bronsted acid. He called that as a Bronsted acid, and he called as water as a Bronsted base. Okay, but after that, when the hydrogen is adding with the H2O, this is this is forming H3O, and chloride ions are remaining. So this he called as, this is basically acid. Okay, he called the acid, but conjugated of base. This hydronium ion, basically see, that is an acid and that is a base, but base of what? This is the base of conjugated acid, because it is forming from the base and it is forming from the water, so that's why we are calling it a acid, but conjugated of base of conjugated acid. Understand? With the help of next example, you can easily understand. So hydrogen is basically reacting with the lone pair of the oxygen. They are having lone pair. Okay, so yeah, if you talk about the, as you guys all know, the oxygen is having the positive ion. Here we are writing a positive ion. Why? Because this is giving the lone pair, that's why we are writing a positive ion. If we talk about the H2O, but H2O is basically a neutral. It will dissolve with acid and base too. We are calling that as an amphoteric too, because it is basically converting into the ions. But here we are calling water as a base because it is reacting with the acid. If we're talking about this, it will neutralize into the ions. So ionization is not a chemical reaction. In chemical reaction, if we are matching with the acid, so that way we are calling as a base, and if we make matching with the base, and that way we are calling as a acid. With the help of an example, you can easily understand. So this is not a acid and not a base, water, but if it's joining with the chemical reaction, so we are calling that as a base or a acid. For example, HCl. HCl is basically what? HCl is basically strong acid. It will give the chloride ions, as you guys all know. So this is what? This is the weak. This is the weak base. If we talk about CH3, okay, this is basically a weak acid, but it will give a strong base. So weak acid will give a weak base, strong acid will give a weak base, and weak acid will give a strong base. This is opposite. For example, you can take the example. For example, okay, you can take this as example. Okay, plus H2O. This is what? This is a weak acid. This is weak acid, and this is weak base. Okay, the forming of the product, this is joined with this will make H3O, hydronium ion, plus CH3COO. We are calling that as a strong acid, and we are calling that as a strong base. So that is relative strength, we are calling that as. Okay, when the weak acid is basically, you can say that weak acid will always give up strong base. Weak acid will always give a strong base. With another example, that is ammonia. When it is reacting with the H2O, this is what? This is a Bronsted acid, and this is a Bronsted base. When it is combining, so it is making the hydronium ion, and this is the acid. This is a conjugated acid of base. because it is related with this. Conjugated word means the relation, and here NH3 is remaining. So this is the base of acid. So that's why we are calling that the conjugated. So if we talk about the example of the, you can say that the minerals, all the minerals are basically all the minerals are basically the strong acid. Remember that. And all the organic compound are basically the, you can say, weak acid. They are inorganic, and they are organic, this is inorganic. Okay, you can take the example of the inorganic HCl, sulfuric acid, H2SO4, many other, and here we are having the hydrogen fluoride and many other things too. Okay, if we talk about the base, for example, this is a salt. This is a salt, but salt is basic or acid? That for that we are having, after solution we can identify. So for example, this is H2O. Okay, so this one COO3 is basically joining with hydrogen, and Na is basically joining with the hydroxide. So the compound will make, that is NaOH plus H2CO3. So this is what? This is a strong base, as you guys all know. Sodium hydroxide, strong base. So this is a strong base. So that's why we are calling that as this compound as a strong base. This is a strong base salt. This is a basic salt. Okay. Next we are having that the property that I'm telling you guys about is that, for example, I'm taking a, this is basically I'm taking a neutral, this is neutral compound. This is neither base or neither acid. For identify, we are having water. Okay, so it will make a strong base. So we are calling that as a basic salt. Before that was neutral, but it's forming a strong base. So that's why we're calling that a basic salt. Next example, NaCl, if we are joining with water. So this is forming NaOH plus HCl. So this is a strong base, and this is a strong acid. These both are strong. So NaCl is basically neutral. This is neither acid or neither base. So we are calling that as a neutral in the solution with the H2O. You can take the example of ammonium chloride plus, you can say that we are adding that with the water. So this ammonium will react with this one, and chloride will react with the hydrogen. So the ammonium hydroxide will be formed plus HCl. So this is the weak base, and this is a strong acid. So this is a strong acid, so that's why we are calling that as a strong acid salt. So the compound which is basically strong, the things in the water basically that is strong, so we are calling that strong thing as a compound. Okay, you can take the another example. So this will be having more character in water as compared, this will be having more character, that's why we are calling that as acid. This strong acid will be having a more character, that's why we are calling that as a, no, these both are equal, they are both strong, so we are calling it the neutral. If we talk about this, so this will make a strong base in the solution, so that's why we are calling that the basic. If we are talking about the sodium carbonate plus H2O, so that will form sodium hydroxide plus hydrogen carbonate. So this is a strong base, and this is weak acid. So I have told you guys that if a compound is basically making a more character of a water, so that is a strong, so this is strong base, so that's why we are calling that as a strong base. So the more character of a of a compound which is in the water and that is strong. So that's why we are calling that compound as a character that is basically more in the water. So this was about the overview that how the strong base and this neutral things are made. But this was about the conjugated molecule. So this is basically, here you can see that this is Bronsted acid, the Bronsted base. So this is basically acid but conjugated of base, because it is made up of the from the base, and this is made from the acid. So that's why we are calling that as a base, but the conjugated acid. From conjugated word means relate, that is related to the HCl, and H2O that is related with the H3O. So that's why we are calling that the acid, but the conjugated of the base. So this was about the conjugated molecules that was given by a scientist, that was Bronsted and Lowry.